Okay, ladies and gentlemen, we are in Unit 6, Lesson 1, the equation of a line in slope y-intercept form. So now we talked about why we give each form a name. It's to differentiate it from other forms, which means you're going to be learning more than one form of a line. You're already pretty familiar with y equals mx plus b. Y equals mx plus b. Just give me, again, what do these parameters mean? What does m represent? Slope, which is rise over run.
B equals the y-intercept.
And b is the y-intercept, otherwise known as the initial value. And then, once we have these parameters filled in, once we've replaced b with a number and m with a number, then we have an equation that relates y to x. That means no matter what x is, we can always figure out what y is, because m and b won't change for this equation. M is a constant of variance, which means it's the slope. The line will always be changing at the same rate.
Is there
Okay?
a possibility that it doesn't change the same rate?
If the line did not change at the same rate, it would be a curve, which you learn about not today. Okay, here we go. Example 1, all we have to do is identify the slope and the y-intercept for each linear relation. And then we're going to use those values to write the equation of the line. Okay? Now, I would start with my y-intercept. And again, I'm just going to call it b, because you know that in the equation y equals mx plus b, b is the y-intercept. We wrote it right there. It's the initial value. So if you're looking at that graph in A, you're looking at the place where the line crosses the y-axis. That's the y-intercept. Okay? So what is that value? -5. Can everybody find that the y-coordinate of the place where, the point where the line crosses the y-axis is -5? So that's our initial value. Another way to say that is your y-intercept occurs where x equals 0. So on your graph, you just look for where x equals 0, which is that line, the y-intercept, and y is -5 there. Good, and now we're going to find our slope. Now, in order to find our slope, we're going to use 2 points on the graph. So we're going to make a note there. To find slope, comma, use 2 points on the graph. Well, we already know the y-intercept, so why don't we use that point as one of our points? That point, remember, is x is 0, y is -5. That's how you name a place on the graph. Can you look at the graph and go ahead and choose another point that we could use? So you want to find a place that goes right through the grid kind of nicely, that you can see it easy.
0, -5, or 0, 5?
That's not on the graph. So your x value comes first.
Oh, 5, 0.
5, 0 is not on the graph.
What are we looking for?
You're looking for, the line goes through an infinite number of points. So you're trying to give me coordinates that the line
7,
goes through. Okay? Does it exactly go through 7, 0? No, it does not.
6, 8, 1.
Ah,
6, 1.
6, 1?
No.
6, -1.
Ah, 6, -1. Sure. Let's use 6, -1. Take a second, make sure you understand what we just did. Can everyone find the point 6, -1 and see that it goes through the graph? Okay, here it is for a second. We chose this as one of our points, 0, -5. And over here we saw that it goes perfectly through the square, through the corner of the square at 6, -1. Is there another point we could have chosen?
Yeah. 4,
3, -4.
3.
3, -3 we could have chosen. Okay? All right, well, now that we have 2 points, how do I calculate my slope?
M equals y2 minus y1. M equals x.
All right, here we go. M equals y2 minus y1 over x2 minus x1. We'll call this point over here x2, y2. Okay, we'll call this point over here x1, y1. So we've got y2, and by the way, you're just plugging in your exact values as they're written. y2 is -1. So where I see y2, I put -1. And then I have a minus sign. y1 is -5. So watch what happens here. I'm just putting in -5 where I see it. I haven't changed anything. Okay, I've just substituted in my values. x2 is 6. x1 is 0. And now I'm performing some algebra on this. Okay? This is just adding and subtracting with integers. -1 minus -5
4.
is the same as -1 plus 5. So you think about your number line. I'm starting on the negative side. I'm jumping to the positive side. There's going to be 4 positives. 6 minus 0 is easy. 4 over 6. Is that good enough?
No.
No. I have to reduce it to 2 over 3. Well, at this point, I might box. I found my slope. I found my initial value. And the goal, remember, is to use these values to write an equation for the line. So, go ahead and write the equation for this line.
I know this.
Oh, 2/3.
Y equals
negative
2/3 x
Oh yeah.
minus 5. Just minus 5. Yeah?
I know how to
Okay.
do that, but I don't know what it means. Like what that equation.
And you can't solve
Uh,
x or
Then
y.
you can't do it if you don't.
Sorry, I'm just
No, I
gonna
know what it
I'm gonna pick up on a little bit of confusion that just happened. Pay attention. So our original equation is y equals mx plus b. So you're right. I could have written it like this. Y equals m is 2/3. So just swap it out straight up. Okay. You don't have to guess. You don't have to think hard. M is 2/3. So where you see an m, put 2/3 x. And then you're right. The equation should be plus -5. But plus -5 is minus 5. Okay, same thing. Does that make sense? So this is not a final answer. You would need to reduce this to this one.
Those two.
Okay?
Never mind.
Instead of plus -5, you just have minus 5. And that's the equation that represents that line. Notice how there's arrows on the end of that line? It goes infinitely up and it goes infinitely down. But this equation includes, accounts for every single point that's on that line from positive infinity x or x equals negative infinity. All of them. Okay? They're all on there. Let's check a point just so I can prove to you that this is true. We already know all the points on the line, but I'm going to say let's just x equals 3. Let's find out what y is when x equals 3. Okay, so I'm going to take this line that we've drawn, this equation, y equals 2/3 x minus 5. And I'm going to say, well, let's say x equals 3. Let's find out what y is. Put 3 in there. 2 divided by 3 times 3, that's just 2. Minus 5 equals -3. Is the point, we said x is 3, is the point 3, -3 on the line?
Yes.
Yes, it is. Okay?
Oh, mind
It
blown. Bam.
We could pick x equals 7, and we would get the matching y that is on the line. The line would go through that point. Okay? You could pick x equals 400,826.748. Chuck that in the equation. Find the y. The line will go through that point.
I know how to
Jacob.
do it, but I
Are
never
we never
thought
solving for y?
In B of example 1, you have a new line. Again, we're going to identify the y-intercept. Where's the initial value? Put it in your head. Don't call it out. Find the initial value on the graph. That's the value when x equals 0. Good. What is it? 3. Excellent. Now to find our slope, we're going to use the same steps as last time. We're going to choose 2 points that we can see on our graph. So we're going to use, we found out that 0, 3 is on the graph. Does that make sense to everyone? Can everyone automatically do that?
Yes.
We found out the initial value is 3. That's the same as saying when x is 0, y is 3. That means 0, 3 is on the line. It must be, because we already said it up there. Okay?
Oh, we're only finding the y-intercept, not the
We need, in order to calculate slope, we need 2 points.
2
So
negative
that
1.
is 2, negative 1 on the graph.
Yes.
Where 0 and
Looks like it, yes. So let's use 2, negative 1. Now, m equals y2 minus y1 over x2 minus x1. Sub in my values. Y2 is negative 1. Y1 is 3, so I have negative 1 minus 3 in the numerator. In the denominator, I have x2, which is 2, and minus x1, which was 0. It makes that pretty easy. So I have negative 1 minus 3, negative 4. And the denominator, I have 2 minus 0, which is 2. And when I reduce that, 4 over 2 is 2. And my negative sign goes out front. Okay? So now be careful. This has an invisible 1 underneath because it's rise over run. So this, when you see a slope of just negative 2, that means we're going down 2 every time we move over 1. So this slope of this,
right? Negative 2 is m.
correct. M is negative 2. All right. We have B and we have M. So can we finish off our formula, our equation for the line? What's the equation of the line?
Negative.
Careful. Y
Y
equals negative 2x
plus 3.
plus 3. Beautiful. Way to go, guys.
Thanks, Bobby.
Go ahead and have a look at the next picture, C, and tell me how it's different.
There's no
what is
points.
going on with it.
Yes, there is.
What kind of line is it?
It's
It's-
a straight
it's
line.
line.
They're all straight lines. It's a horizontal line. So if you're thinking about rise over run, it's running. It's running. There's no rise, okay? Let's see what happens here. Let's start with our initial value.
4.
The initial value is 4, because that's the value when x equals 0.
How do you know which one?
The blue
The
one.
other one goes over 0.
The other one is the axis. Yeah,
Because
we're looking.
it shows you where
X
x
by
is.
it.
It shows you under the line where x is.
Okay, so here we go. Now we're calculating our slope, and we're going to do it the same way, and you'll see what happens. We've got y2 minus y1 over x2 minus x1. And we need 2 points. You've already decided that we can use the points 0, 4. Can you think of another point that we can use?
Yes, 4, 0.
Is 4, 0 on the graph?
Yeah.
No, sir.
No, siree.
Yeah, 4 zeros on the graph, no?
3, 0?
Nope.
Nothing.
4.
Ah, 2, 4 is on the graph.
1, 4.
1, 4 is on the graph.
It's about to-
Is 3, 4 on the graph?
No. Yes, it is. It's
Yes.
continuous.
Is negative 2, 4 on the graph?
Yeah.
Yes.
No.
Is
Yes.
negative 1, 4 on the graph?
Yes.
Yes. So anything with a y coordinate of 4 is going to be on the graph?
Yes.
So y will always equal 4?
Yes.
Let's watch what happens. So let's sub in our values. y2 minus y1 is 4 minus 4. Uh-oh, what happened?
We became 0.
Oh,
Our
no.
run is x2 minus x1. That's 2 minus 0.
No.
So we're left with 0 over 2, which is just 0.
Oh.
So our slope is 0.
You could have just.
That makes sense because it didn't rise.
Can we just say
Zero.
that? Instead of doing that?
Okay, 0 over 2. And our initial value is 4. So watch what happens when we plug this in to our equation of a line. Okay, let's plug in m. M is 0, so we have 0 times x. And b is 4, so we have plus 4. Well, 0 times x is,
0.
what if x is 10?
Zero.
What if x is 7?
Zero.
What if x is -1?
Zero.
What if x is an apple?
1.
0.
Zero.
If it's an apple, it's
Joking.
one.
Okay. Y equals
4.
4. The equation of a horizontal line is in the form y equals a constant. Y will always be 4. Okay? Let's make a little note here. Hopefully you have some space. This is a horizontal line. Period. It has no rise. Period. The slope of a horizontal line will always be 0. Okay?
So does that mean that the y-intercept would always, like, the constant would always be the y-intercept in that situation?
Correct. Yep.
So the y-intercept
So
is the answer.
basically what it's saying is that y equals 4 is enough information to draw that line infinitely. If y equals 4 here, and 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 everywhere in between, put an arrow, forever. Okay? Y equals 4 is enough information to describe that line perfectly and entirely. Excellent. Go ahead and look ahead at number D and describe that line.
You can't do this one.
Yes, you can.
We can't.
Oh.
What was the one line that we can ever do then? This one. This
It's just a
one.
vertical line.
No, but there was one line that we can never ever figure out.
It's undefined.
Yeah, this one- this one's
Undefined.
undefined.
All right, so let's talk about the y-intercept.
What?
2.
There is
Y-intercept.
Oh, there is that.
Sam, stick with it. Jaden, look for the y-intercept.
I already
Where is it?
There is none.
There is not a y-intercept. Okay? So in a vertical line, there is no y-intercept. Well,
Unless it's right on 0.
let's make that note. A vertical line has no y-intercept. Yeah, I don't know how to actually explain that. What if the vertical line was right
It's
on
everywhere.
x
It's
equals
everywhere.
0? Then it would
Because
be
then
an
there would be
infinite.
no line. It would,
It
just
would
be
never
the
actually
axis.
cross. It would be on that
Nah,
line.
it's
It's
crazy.
okay. Well, let's try to calculate our slope. Let's see what happens here. So we need 2 points. We know that. Well, just give me 2 points that are on the graph.
0,
2.
2, 0. No.
Two-
We don't
2,
have
0, yeah.
2, 0 is on it,
And 2, 2.
and 2, 2 is on it.
We're still doing solving.
Do we know what's going to happen?
It's going to
We're
become
not going to be
0.
able to solve it.
Let's fill in for our numerator. Our change in y is 2 minus 0. That's okay so far. Our change in x is 2 minus 2. So I've got 2 over 0.
And that just doesn't
Undefined.
work.
Undefined.
It's
2,
0.
correct. It's not 0.
That's fine.
It's undefined. So division
Anything is possible.
division by 0. So when 0 is in the denominator, is undefined.
When I type it,
Here's what you need to know. A vertical line, same page. A vertical line cannot be expressed in the form y equals mx plus b. Okay, look at the graph of the line. What do you notice about its x-intercept?
It crosses at 2 or 0, 2.
The x-intercept is 2, right? So every single point on the line, like we had 2, 0 and 2, 2, is 2, 4 on the line.
Yes.
Is 2 7 on the line?
Yes.
Is 2 negative 5 on the line? Is 2 negative 7 million on the line?
Yes.
Yes. So 2 is always the x coordinate of every single point on the line. Okay, so the line goes through x equals 2. Or another way to say it is the line actually is x equals 2. So the equation for this line is x equals 2. Just like with a horizontal line, y equals something, in this case y equals b, was enough information for all that line. In a vertical line, x equals something is enough information to explain that whole line. It just means y will never change, it just means x will never change. Y might change, but x will always stay the same. That's every point on this line. Okay? One more little note on the bottom there. This means that for any point on the line, the x coordinate is 2. No matter what the y coordinate is, the x coordinate will be 2. In example 1, you determine the slope and the y-intercept and an equation just by looking at the graph. Now we're going to develop an equation by being given m and b. Alright, so let's look at A. A, they tell you that m is 3 over 4 and b is negative 2. So, let's write our equation. Y equals mx plus b. And sub in what we know. M is 3 over 4. So we have y equals 3 over 4 times x. And b is negative 2. So we have plus negative 2, which is just minus 2. And that's the equation of our line. Now we're asked to graph it. Now what's the best way to graph this line?
Put negative 2 on the 0 line.
Good. Start with your initial value at 0, negative 2.
Won't the line be like down?
Oh yeah. Oh boy. One mistake.
Oh.
Good job. Okay, 0, negative 2, which is going to be down here. And now what do we do?
This is where I get confused.
You don't have to get confused. There's only one other thing here.
I don't know how to do it.
Stop.
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 75.
Well, there's a way easier way, guys.
3 over 4.
Rise, run.
Times them.
No.
You
It's
go up
opposite.
3 over 4.
Stop it. Stop thinking about crazy off the wall things. It's literally right in front of your face. Go up 3, because that's the rise, and you go over 4. When you come to a flight of stairs, do you think, oh, what do I do? Do I go this way? No, you go up a step, over a step. Up a step, over a
I'm on
step.
the walls.
Okay? Thankfully, we don't have a breakdown every time we come to a flight of stairs. Up 3, run a 4. Up 3, run a 4. You do yours perfectly. Okay? Your line should end up looking something like this. Remember, a line goes forever.
So we have to put the arrow thing?
Really,
Yep.
Mr. B, it doesn't matter how many times you go up 3 over 4 because it's a line, right?
Correct. You could go up 6
So
over
I
8.
was always thinking, why do you...
So we go over 4, up
So really,
3.
my point could be right there where you...
over 4, up 3. You want to do it a few times so that you're consistent. Over 4, up 3. Okay, make sure your image looks something like this,
Did you
and
put numbers
maybe
down?
even label run, rise, run, rise,
I thought you did rise first
Run.
and then run.
rise. Doesn't matter what order you do them in, as long as you do them correctly. I have to label the rise, right? This is the rise. Can't label it run.
Wait,
I had to
is
read
it rise?
I did it opposite and I got the same.
No. You can, if it helps you. All right, so real simple. I get my starting point. Just a quick review. You get your starting point, your initial value, okay? And then you have your slope. Rise, run. Rise of 3, run of 4. Rise of 3, run of 4. Okay? B. B, your m is negative 3.
You do this one by yourself.
Yes. And your b is, your initial value is 0. So you've got your base equation here, y equals mx plus b. Once you've filled that in, you can double check the board to make sure you've done it properly. And then you can draw your graph.
Oh, so it's going to be horizontal?
Not necessarily.
I was
That
thinking
would be
negative
that would be
37
y equals b.
Is
Okay.
m
But b equals
Negative
0, which
three
means
over
we'll start
one.
at 0.
You start at 0, 0, correct?
Then you go down 3.
Down 3
So it's worse.
over 1.
Why do you go over? Oh,
Because it has
Down
an
three.
dimension. It's 3 over 1.
Over 1.
Oh, that's where it gets me. It's over 1. Ah. I see.
Yes, senor.
Yes, sir.
So your graph should look something like that. And another key, guys, when you're drawing graphs, actually, and we didn't do it on A, but you label your line every single time. So I've drawn the graph of y equals negative 3x. Okay? All that means is it has an initial value of 0, 0. Is this partial variation or direct variation? Direct variation, because it goes through 0, 0. And the slope is negative 3, or the constant of variation is negative 3. So whatever happens to x, you're going to multiply it by negative 3 and you'll get y. You could find out what y is when x is 4. Just put 4 in here.
Rise over run if it's going down. Yeah.
Yep, because the rise is negative. It's a negative rise.
So it's a negative rise.
Correct. All right, let's look at C. C says a slope of negative 1/2
Does that cancel out?
and y-intercept of 5. I'm going to ask you just to slow down your brains, okay? So this part here, you're going to, maybe this is the tricky part, okay? This part here, the slope is negative. So is this line going up or down? It's going down, okay? Now, pay attention. What would happen if I represented this as negative 1 over negative 2? It would be positive. That's not correct. You may think of the rise as negative or the run as negative. You will get the exact same result,
Not both.
but not both.
Uh,
My suggestion is that you always think of this as the rise, so that you're just always reading left to right. Your run is always positive, but now every time I go down over 2, I'm going to go down 1. Over 2, down 1. Over 2, down 1. Is that making sense?
Wait. You start at 1, right? Negative
Well,
one.
you're right. I jumped
Yeah,
ahead
no,
just to give you.
I did that.
Okay.
Already.
you
Okay.
start at 5.
I did the 5.
Okay, so you have your initial value up here at 5.
Yeah.
And now we're going over 2, down 1. Over 2, down 1.
Oh.
So your line should look something
Okay.
like that.
No.
Just trivia, it's not on your graph, but if your graph kept going and going and going, which it does, you just didn't draw it, think about it, don't call it out. What's this point going to be right here?
X.
What's the x value here? So it is the x-intercept, but what's the value going to be?
I know something 0.
So you're starting at, good, 10. You're starting at y equals 5, and then you're going to go over 2, down 1.
You're timesing it by 2.
So by the time you go down 5, you'll have run negative you'll have run
This is
10.
easy. I get it.
Okay?
The only thing I get confused about
And then
is when
we need to
do-
remember to label it y equals negative 1/2 x plus
What do you
5.
mean when we do?
Mr. B, I always think that like when you
D, here we go. We're given m of 0 and a b of 6.
Okay, this is a vertical now.
Careful. Slope is 0, not undefined. Slope is 0, and the initial value is 6. So why not plug it into your equation? mx plus b, y equals 0 times x plus 6.
Wouldn't you just do plus 6?
Y equals 6. And now when you're plotting your grid, you know that not only is the initial value 6,
Done.
but every single point on the graph has a y coordinate of 6. What kind of line is this? A horizontal line.
Don't you
Has
have to move
no
down
slope. You're not moving down it. There is no slope.
It has
Slope
a
is
run of
0.
six, right? Oh, no, never mind.
No.
Right? So it's you could think of the slope as 0 over 1 or 0 over 2 or 0 over 10 or 0 over, get where I'm going with this? It's
Yeah.
always going to be 0 no matter how much you run.
Mr. B, if it's 0 over 1, don't you have to go right? Don't you have to go up?
Rise, run. You run one, you don't rise at all. You run another one, you don't rise at all. You run another one, you don't rise at all. You run 10 more, you don't rise. You run infinitely this way and infinitely this way, and you never rise. It's a horizontal line. Good job. In example 3, we're asked to interpret a linear relation. So we've got two graphs there. We don't have the slope or the y-intercept given, but we could determine it. And basically we're going to talk about those things, slope and vertical intercept of each linear relation, and then explain what they mean, and we're going to write an equation to describe it. So first we're just going to talk about the situation, and then we will write an equation. So what's happening? What kind of graph is graph A?
I just sent you a negative graph.
Okay, good. Two answers. One is it's linear, straight line. One is the slope is negative. It's descending. Okay? What are the variables?
Oh, 5 is the y-intercept.
What are the variables? Yes?
Time and distance.
Time and distance. So this is a distance-time relationship. So we're actually talking about Tracy's, what's her slope represent then if it's distance over time?
Her walk. Her time
Or
travel.
time travel per meter over meter.
Which another, good. So distance per meter, kilometers per hour is a unit of measuring your car's, starts with an S.
Yeah.
She can walk
Speed.
5 meters in 10
Okay.
seconds.
So here we go. This is, let's say, let's take a couple notes here. Do you have space for notes? This
No.
is a distance hyphen time graph. Okay? The d-intercept, check that out. We used d because that's our variable, right? And it says so in the graph. Our distance intercept is what, Sam?
5.
5. Good job. Which means, what does that mean?
But b equals 5.
Okay, yeah. But let's describe it in words. What's Tracy doing here? Why is she starting? She's not starting at 0 and walking away from something.
She's walking backwards.
She's walking either backwards or just back towards something. So, which means Tracy begins 5 meters away from the start
That's a big word.
and walks toward the start. Okay. Let's determine her slope. So we already know that d-intercept is going to be 5. Let's determine her slope. What do we need in order to determine slope again? We need 2 points on the line.
Can we do it by
Okay?
ourselves?
Yep, go ahead and pick 2 points on the line. Or just follow the line counting squares. is a really easy way.
Wait, don't we just use our 2 points and then?
You could use your 2 points.
Alright, I like that, buddy.
We have 2 points. We don't have 2 points.
Yeah, we do. 5 and 10. Yeah.
Hold on. If you're going to do that, Sam, then make sure that your points are 0, 5,
And
0,
0,
10, and 0.
and 10, 0.
Yes. Oh yeah.
Because you always.
Oh, the interest
Okay?
rate.
I messed
I
up.
already figured
That's a little bit confusing. So I'm going to show you an easier way to do it.
It's
If you're looking at your graph, which is printed there for you, right here, she's going to go down 1 meter over 2 seconds. Okay? She's going down 1 block and over 2 blocks. And both of my axes have a scale of 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And up here, 1, 2, 3, 4, 5. Okay, so they both have a scale of 1, which means I can just count blocks. She's going down 1 over 2.
Oh. So you don't even have to do all your figuring out what's in.
Correct. You can just look at the squares in this situation.
Yeah, but that
that
Doesn't always work, you're right. So she has a slope of negative 0.5. What does her slope represent?
That is insane. Her going backwards.
Okay, the negative tells us that she's going toward the start.
Which is actually the finish line.
I know that what the slope is. It's negative 1 over 2.
Yep.
We figured that out.
Yeah, I know, but I
Good. The slope represents her
Distance, speed
Her
over
speed.
time. Or, yeah.
her speed. And then in brackets you can say distance over time. Good. You're doing really good. So it means her speed is 0.5 meters per second backwards. Right? So let's write an equation for this. We're relating, what are our variables again? In this situation? D and T. So D relates to T. Yeah? D varies indirectly with T.
Do we have to switch them?
So we got D equals slope goes in the same spot as it always does. Negative 0.5 T, which is our independent variable. And where is she starting from? Plus 5.
Why is it?
Can we to, like, just remember it better, can we write y equals mx plus b and then do d?
And then sub it in?
Yeah.
Sure. As a matter of fact, on the top of your homework page, you should just write y equals mx plus b. And then you should write m equals y2 minus y1 over x2 minus x1.
Mr. B, question.
Okay, and then you'll have that there for all of
Wouldn't
your
it be
references.
easier-
All right, take a good look at that second image, guys. Take a good look at the second graph. The title is The Height of Tomato Plant After Planting. So did they start from seed or did they buy a potted plant?
Buy a potted plant.
How do you know that they bought a
It starts at 6.
It already has a height, okay? Sam and Jacob, stick with it. Okay, you know that she bought a potted plant because it already has a height. So you know the initial value or the initial height.
6.
So in B, initial height equals 6 centimeters. So that's the height that the plant was when she bought it. Can you calculate the slope? Be careful, the scales are different on this one.
It's by 2.
It's going up by 2s, so your rise is by 2s,
So every
What are you doing?
and your run is by 1.
No, we should do it the real way, Mr. B.
no, we
This
should
is
not.
a real way, Sam.
You can't just look at a graph every time. Sometimes it's going to be really big.
But there's not just one real way.
Yeah, there's multiple.
There's multiple ways.
Learn all the ways, not just one.
Okay,
way.
so
Mr.
let's
B,
take
shouldn't you do the, like,
Let's take a good look at it. We're starting here at 0, 6. If you want to do y2 minus y1 over x2 minus x1, go for it, but not now, because you're going to learn this way. Okay? Starting here, if you go to the right 1 block, that's a run of 1 week. That's fine. If we go up 2 blocks, how big of a rise is that?
2.
No.
Oh,
Look at
4.
4. Because every block on the left axis, on the vertical axis, is going up by 2. So if you go up 2 blocks, that's actually 4 centimeters. It's not hard to see it. It's right there in front of your face. Sorry, that was rude. It's on video too now. Okay, so go over 1 week. Whenever you go over 1 week, you're going up 4 centimeters.
Maybe not.
Oh wow, look at that.
Oh, yes, you are.
Okay, so your rise over run is 4 over 1, which reduces to
4.
just 4. And your initial height is 6. So let's talk about our variables. Which variables are we using?
Time and height.
So height is our dependent,
Y equals mx.
time is our independent, and the slope or the constant of variation, every week it's going to grow 4 centimeters. So 4 times t, where t is the number of weeks, and then our initial value, starting at a height of 6 centimeters. Okay? Now what's interesting about this is what if she had started with a seed and then actually buried the seed 2 centimeters underground?
Yeah, what if
We'd
it's
have
a
an
giant
initial
number
value
of
that was
organisms?
-2. Okay?
That's not what we're doing.
Sea level.
Question. Miss V.
I'm going to ask you one more question. It's an extension of this. How tall is her plant in week 7? Don't answer out loud. How tall is her plant in week 7? No guessing. You will know the exact number. How tall is her plant in week 7? So when t equals 7, what does h equal? Don't call it out. Do the math. You can go ahead and check the board to see how you did.
Mr.
Okay.
V, you can't use this method for like really big graphs, right?
Okay, let's quick look down. No, if you're, no, probably not. If it's not clear, then you can't use it.
Maybe you should
Yeah.
use rise up for
Yep. Okay, key concepts, real quick, to wrap up today's lesson. The equation, pay attention, see if you can fill in these lines. The equation of a line can be written in slope y-intercept form, which is,
Y equals mx+b.
go ahead,
Y2.
y equals mx plus b, where is the slope of the line,
B.
m is the slope of the line,
Yeah.
and is the y-intercept. A horizontal line is written in the form
Y.
y equals b, where b is the
Y
y-intercept. Good. There is no rise over run.
It's horizontal.
It's has a and the slope of the line is
Zero.
0. Good job.
Okay. Vertical line.
A vertical line is written in the form x equals a.
What? Oh yeah.
Okay, a just means any number,
Okay. Next.
whatever number it goes through. Where a is the, how do we know?
Intercept.
Good, it's the x-intercept. And the slope of a vertical line is, it's not 0, undefined. 0 is a good number. 0 is just as important, if not more important, than all the other numbers. 0 is a good slope. Okay? 0 in the denominator, undefined. Your practice problems are written there for you. It's page 506, numbers 1 through 13. That's giving you review on coordinates. Okay, so it's not directly related to this. It's like you have to have that knowledge in order to do the rest of it. Then page 522, 14C, and then the worksheet on page 9 in your workbook. And yes, you may answer the questions directly in the workbook this time. Enjoy.
Can we